Hello. We're starting the second to the last chapter on General Path. I guess that's what they call the penultimate chapter, and I feel really good about this. I've had a little bit of a lag in making these movies because I don't know, I guess I'm getting like writer's cramp or doctor's cramp, or I don't know what they call it, but I've been getting so many letters and comments and emails that are so overwhelmingly positive. I don't feel anymore like I'm just speaking to a bunch of friends. I feel like I have a world duty, and it scares the hell out of me. So I don't know. I guess I just got a little bit spooked about the whole thing. Anyway, we'll start this chapter today: environmental and nutritional pathology. One of the most well organized chapters in the book. And, the field of environmental and nutritional pathology is actually sort of new. It was not in the old Stone Age editions of Robbins, which I read many years ago. It's something that has resulted because of political correctness and the fact that a lot of things like toxicology or toxic pathology just didn't quite seem to fit anywhere and had to be thrown in here or there. So this is a great place for it. We'll be talking about environment, toxins, nutrition in this particular chapter. So we'll be talking about how substances in the environment interacting with our cells, our bodies, cause diseases. If you want to call that exposures, you can. They can be environmental or they can be occupational, which is a type of environmental in which certain people are exposed more than others by virtue of what they do. We're also going to get a little bit into nutrition and, in particular, deficiencies or lack of proper nutrition causing disease states. And speaking of occupational diseases, I think you should keep in mind that there are a lot of ways you could classify it, and I think it's important how you classify it because it means a lot of money that governments, our government, has to spend out every year. But keep the focus on the fact that the vast majority of occupational diseases are repeated trauma. And even though you can classify things into skin diseases, lung diseases, poisonings, dust, and all this other stuff, in terms of payout, in terms of importance, the most important thing, 2/3 of all the reported occupational diseases are due to repeated trauma. And when you talk about exposures of toxic substances in the environment to enter our body, we have to go into several basic concepts before we mention a few. The first of all, we'll be saying a little bit about the threshold effect, and then we'll talk about the ways which the toxins enter the body. And when you think about it, there's really only 3 ways they can. If you remember your anatomy and histology, I really can't think of anything entering the body if it's not ingested, inhaled, or comes into skin contact. We'll talk about distribution of toxic substances in the body, their metabolism, their excretion, and some of their effects as well. Did you ever wonder? No, let's talk about xenobiotics, which is the same thing we just mentioned. Xenobiotics are substances which enter our body. They're foreign, and that's why they get the name xeno, like a xenograft. And there are different ways our bodies handle these. Now, if you remember, in order for something to enter a cell, it has to become polar or it has to become relatively nonpolar because the membrane of the cell is a lipid membrane, so it doesn't allow things that are directly polar. It has to be relatively nonpolar. Our body reacts to making substances less nonpolar or less lipophilic or more polar by doing basically 2 things. One is to modify the molecule, phase 1, by adding a direct polar group onto the molecule, and the other is to conjugate it, which is called a phase 2 reaction, by virtue of combining it with another polar substance. There's a little bit of a difference here. In one case, you're adding something on. In one case, you're combining something. So the systems of enzymes in the body, which are result in phase one uh, reactions or modification, are the cytochrome-dependent monooxygenases, the flavin-containing monooxygenase system, and the peroxidase co-oxidation systems. These are all systems in which substances are given a polar group to make them more polar or less nonpolar, and therefore less likely to enter the cell. In conjugation, you add a completely new molecule onto the substance, also making it less lipophilic. And of course, the most common situation that, as an example of that, would be glucuronidation, but then biomethylation and glutathione conjugation are also methods by which toxins are combining with other substances to make them more polar. And this is pretty much a nice little diagram of what we have just mentioned. You have an exposure of a compound. It is absorbed at the three different portals of the body, the oral cavity, the lungs, the skin, and is distributed within the body. Now, it could be metabolized to become more toxic, or it could be metabolized to become less toxic. And it could become less toxic through these phase 1 or phase 2 reactions, and of course phase 2 is conjugation. If it's less toxic, it could very easily be excreted. In fact, one of the purposes of combining and conjugating compounds is to make them more likely to be excreted. On the other hand, these conjugated compounds are still technically within that component or compartment of the body of distribution as well. If the compound is toxic, it is further distributed into areas. It can interact with the various molecules in the cell and organelles, the proteins, DNA, RNA, and so forth. This is where it does its damage. It could be the genetic damage, a carcinogenic damage, reproductive damage. In every case, we're talking about direct damage to DNA, RNA, and proteins and receptors. There can be a turnover and repair of the cells, and the substances can be ultimately excreted. So this is basically how you should look at the distribution of toxic substances which we are in our body from the environment. And speaking of environment, if you've ever wondered what was at toxic waste dumps, I mean, we all hear the term toxic waste, but if you actually had a list of the common things that are stored in the hundreds of toxic waste dumps in our country, we basically have everything from A to Z, acetone to zinc. Some of these compounds you may recognize pretty quickly: aldrin, arsenic, barium, benzene, butanone, cadmium, a lot of heavy metals, carbon tetrachloride, things used industrially chiefly, which are not easily biodegraded, chlordane, chloroform, chromium, cyanides, pesticides, DDT, dichloroethanes, lead mercury, methylene chloride, nickel, pentachlorophenol, polychlorinated bipheноls, tri- and tetrachloroethylenes, toluene, vinyl chloride, zinc. All compounds. What they all share in common is the fact that they're not easily converted or biodegradable into non-toxic compounds, so they have to be stored, and that's why we have toxic waste dumps. When you look at the effect that toxic substances have on our body, basically if you take the concentration of the dose versus the cumulative response, it may be a clinical response, a lab response. These are these are the curves that are used in toxicology studies. Technically, if you have a dosage of a substance that produces no observable clinical effect, that is a sub-threshold dose. At some point in varying the dose, you have a response, and that's called the threshold effect. And then basically, the more of a dose, the more of a response. Ultimately, until it, whether you give, it doesn't really have a additive effect until you get, no matter how much more substance you add. I know I completely screwed up that concept, so let's try it again. There's a point at which additional concentrations of the toxic compound produces no further increase in toxic effects, and that's called the ceiling effect. But the one thing that is extremely important is the so-called threshold level. There is a threshold level for every compound, every toxic compound known to man. Thank you very much.